Hey guys, so today we're going to start by figuring out how to find the circumcenter of a triangle using algebra. So we have a triangle with points at -2, 6, 5, 4, and 1, -1. So the circumcenter is really just the intersection of the perpendicular bisectors of each segment. So that just means a line that is perpendicular to a segment and also cuts it in half. So right here, this would be equal to this part. And we really only need to find 2 to find the actual circumcenter, so we're just going to leave out segment AB for this actual inquiry. So the first thing we need to do is we need to find the slope of segment BC and AC, and also find their perpendicular slopes, because it's a perpendicular bisector, and that's ultimately what we're trying to find. So we're going to be finding our slope of BC by using our slope formula. So we take 4 plus 1, and then 5 minus 1, that'll give us 5 over 4. So our perpendicular bisector slope for BC is actually going to be -4 over 5, because it's that opposite reciprocal. And then the slope of AC, just follow the same format. You get -2, and then 5 plus 2, 7. So you can see that from those 2 points here. -4 minus 6, and then 5 plus 2. And that'll give you a perpendicular slope of AC, or sorry, a perpendicular slope of 7 over 2 for AC. Because once again, emphasize it again, the opposite reciprocal is how you find the perpendicular. Alright, next thing, you need to find the midpoint. Now the midpoint is very important for getting a perpendicular bisector, because these two sides that it bisect need to be the same. So by finding the midpoint, we're ensuring that they will be the same. So we need to start by the way, this is the midpoint formula. So what we're essentially doing here is we're taking 1x from one point, adding it to another x, dividing it by 2, because it's really just an average, and then a y plus another y, adding them up and dividing by 2. So that's what I did here for BC. You do 1 plus 5 over 2, and then -1 plus 4, or just 4 minus 1 over 2, and that should give you the point 3 over 2. And if you do the same thing for AC, you should get -2 plus 5, so I have my -2, my 5, divide that by 2, and then my 6 and my 4, and divide that by 2, so that's just 10 over 2. So you end up getting 3 over 2, 5. So now what we're really trying to do is we're trying to find the lines for these two perpendicular bisectors, because we're ultimately trying to find the actual point of intersection for these two perpendicular bisectors. So we need to find by finding the lines for both BC and AC. So to start with BC, we're actually going to do it the easy way. We're not going to plug it in point slope form. This is just a lot faster, and you can do it in your head a lot faster as well. So we're going to start with y equals mx plus b, and we're going to plug in our slope that we know for BC. So our slope, we realized, was -4, 5. So we say y is equal to -4 over 5 x plus b. Now what we're actually going to do this time is we're going to plug in the midpoint of BC. So the x and y, the midpoint, is what we're going to plug in for the x and y here. So you end up getting 3 over 2 is equal to -4 over 5 times 3 plus b. That simplifies down to -12 over 5 plus b is equal to 3 over 2, and if you add that 12 over 5, you should get 39 over 10 is equal to b. So the line of your perpendicular bisector to BC is really just going to be y is equal to -4 over 5x plus 39 over 10. We can go deep into the math with that, but this is just the good concept of adding that. It's just systems of equality. And then we're going to do the same thing for AC as well. We're going to start with y is equal to 7 over 2x plus b. Plug in the midpoint this time for AC. So we're actually going to get 5 is equal to 7 over 2 times 3 over 2 plus b. So that simplifies down to 5 is equal to 21 over 4, because 7 times 3, 21, 2 times 2, 4. So 5 is equal to 21 over 4 plus b. You subtract the 21 over 4 to 5, and you should get -1/4, or just -1/4. So the perpendicular bisector for segment AC is actually going to be y is equal to 7 over 2x minus 1/4, or 1/4. Alright, so this is my favorite part personally. This is where you actually get to find the point. So the first thing you have to do is solve for x. Since we put them in slope-intercept form already, we can just set the equations equal to each other and solve for x. And I actually just noticed there should be an x here, so ignore that for a moment. So what's going to happen is 7 over 2x minus 1/4, that was our line, and we're going to say that that's equal to negative 4 over 5 plus 39 over 10, and that's technically through substitution. So we're going to add 4 over 5x to 7 over 2x, and that's going to give us 43 over 10x minus 1/4 is equal to 39 over 10. We're going to add 1/4 to say that 43 over 10x is equal to 83 over 20, because that's what we got when we added that 1/4 over. And then since it's 43 over 10 times x, we're going to multiply it by the reciprocal, because that's just how we do division with fractions. So you're just going to do 83 over 20 times 10 over 43. That will give you 830 over 860. Should make that look a bit more realistic. So your x is really just equal to 83 over 86, because you can just divide those two there by 10. So now we're going to plug this x back into one equation. Doesn't matter which equation you use. I chose to use the one for AC. So you say y is equal to 7 over 2 times 83 over 86 minus 1/4. These two, when multiplied by each other, will give you 581 over 172. And I took the liberty to just multiply this so that we have a common denominator. So if the fraction that's going to be equal to 1/4 but has the common denominator of 172 is going to be 43 over 172. And so that'll simplify down to 368 over 172, which will eventually give you 269 over 86. So we're working with some pretty ugly fractions here, but that's just algebra. So that means you're going to take your x, 83 over 86, and your y, 269 over 86, and that's going to be your circumcenter, or the point of intersection for all of your perpendicular bisectors.
Okay, we're going to find the centroid, and that's where all the medians meet. Here are the medians, and this is where they meet. And
so by median, we mean is the midpoint of one segment connected to the opposite vertices. So we have one midpoint here to the opposite vertice to make that the new segment, or the median.
Yeah, first we have to find the midpoints, which is basically finding the average of the x and the y of each.
Which, just to clarify again, you're taking two x's, dividing by 2, or averaging them, and taking two y's, adding them together and dividing by 2 to get the new one.
Yep. And then after we find the midpoints, we just make the line or whatever. But then we had to find the slope of those lines. So we just found the slope of what we named AD, and that was a negative 9/10, and BE, which is 12. And then after finding the slopes, we had to find the lines. So we did that by plugging the slopes and the points into point slope form. And for BE, we got y equals 12x minus 13. And for AD, we got y equals 910x plus 21 over 5. So we get the equation of that line.
And just to clarify, for BE and AD, it doesn't matter if you used the midpoint coordinates. We just thought that it was easier to do math using whole numbers, which is why we used B and A as our points.
And then we set those equations that we just got equal to each other so we can find where they intersect. But we had a fraction, but 10 and 5, they're divisible by each other, so we just multiplied it by 10 so it'd be much easier and we wouldn't have to work with fractions. And then we got x equals 172 over 129, or x equals 4/3. So that was our x of the point of the centroid. So we plugged that into one of the equations to find the y. So we did y equals 12 times 4/3 minus 13, and we got y equals 3. So the centroid is 4/3, 3.
Hey guys, today we're gonna find the orthocenter of the triangle. And all the orthocenter really is just where the vertice of the triangle hits the exterior side at a 90-degree angle. So we only need to find 2 for this. So we only need to find 2 altitudes because the third one will just cross them as well. So first thing we need to do is find the slope of BC. So BC is this right here. And we need to know the perpendicular slope so we can hit it at a 90-degree angle with our altitude. So that's 5/4. and then the slope of AC is -2/7. So we're just gonna find the opposite reciprocal of the slopes, and we're gonna get for BC -4/5 and for AC 7/2. So then we're gonna use point slope form. So to find our line that we need to use to find, and so we get y minus 6 minus 4/5 x plus 2. And then once we solve all this, we get y equals -4/5x plus 22/5. And then we're going to find our other line right here. So we have y plus 1 equals 7/2 x minus 1. And we end up with y equals 7/2x minus 9/2. So then we need to set these equal to find our x. So once we set them equal to each other and we do all the math, we're going to end up with x equals 89/43. And then from this, we can just plug in x to one of our random lines to find y. It doesn't matter which one. And we're going to end up with y equals 118/43. So our orthocenter is 89/43, 118/43.
And just one last thing. So when we're going into point slope form, the point that we just use the perpendicular slope for the opposite vertex that it was connecting to. So in this case, it would be A, and then down here it would have been B. So that's where the point slope form came from, and that would be the main reason why you would have to use that step in order to find the orthocenter and the altitudes. So, thanks for watching.
That's the orthocenter.